Hey Propelland, this is Kyrie and I'm going to be demoing and walking through my project that I've built over the past couple of weeks. OpenLED is a portable IoT sound reactive LED strip that runs off of a Raspberry Pi. Using your phone or browser, you can change its color configuration via HTTP requests. I would be showing it in action, but the hardware broke as I was preparing to film, so all I have is a Snapchat from a bit back. Hey Google, party time. Now, let's dive into the code itself. The backend of the app is built with Flask. Since my hardware is having issues, I'm going to be doing this demo over a droplet on DigitalOcean running Ubuntu. First, I need to start my virtual environment and set the configurations. Let's start with a Google Home demo that sends HTTP requests. Hey Google, let's change it to blue.
It's about to be blue.
Hey Google, it's party time.
It's about to get lit in here.
Using Postman, I can send a post request with a plaintext body for the specific configuration, such as red, blue, green, or even rainbow. Attempting to send the already selected configuration results in an error. If I wanted to check the current configuration, I can simply send a GET request. Now, let's look at the hardware that was used, discuss alternatives, take another look at the software, and go over the to-do list. The main components of the hardware were a WS2812B RGB LED strip, a Raspberry Pi, a sound impact sensor, and a USB microphone. The reason I chose to use the specific LED strip was because of how programmable it is with the NeoPixel library. The Raspberry Pi allows me to use a Linux operating system, which I'm most comfortable with when coding a backend. The sound impact sensor allows me to detect specific beats and react to them. Finally, the USB microphone takes care of the rainbow visualization, since the onboard audio does not work very well. Software libraries that I used included Flask, Subprocess, Bash, Supervisor, Adafruit NeoPixel, If This Then That to handle my Google Home sending HTTP requests with Maker. RPI WS281X takes care of programming the specific pixels on the LED strip. And finally, the audio reactive LED strip is the rainbow visualizer. Many alternatives existed during my research. One solution was to use an ESP8266, which hooks up directly to my computer and allows me to do all the computation outside. However, this option isn't exactly very portable. Secondly was using an Arduino. While an Arduino allows me to do many of the functionalities I've already described, it doesn't allow me to actually develop a backend. Finally, I chose to use Flask instead of a lamp or MeanStack because I don't need something as powerful as them. I'm only setting up a simple server. In my to-do list, the first step is obviously to fix my hardware. Secondly, I want to finish up the Android app. While it's not technically difficult, I'm focusing more on the design and UI, including an authentication portal for people to use. Third, I want to use a low-pass filter to recognize the beats by only registering specific frequencies such as 60 or 100. This way, I no longer need a sound impact sensor, which keeps the package smaller. Finally, the last step is to implement an auto hotspot or Bluetooth option so that I can connect to my Raspberry Pi anywhere. Looking at the Flask code, you can see that I imported many libraries and utilities to build this project. More importantly, I imported Subprocess, which allows me to run shell commands within Python. To begin, I set my defaults, such as current configuration and config options. Looking at how it handles post requests, you will notice that I wrote many if statements to handle errors, making it more user-friendly. Let's assume that the current configuration is green, and I just submitted a post request to change it to red. It will launch the corresponding bash script that logs the change and handles the process. This is done using Supervisor, which stops the running processes and starts the appropriate configuration. I will be demoing Supervisor on my AWS EC2 instance, where I happen to be hosting several bots. By running supervisor control, I can view currently running processes. Looking at the configuration for MusicBot, I can see that it auto starts when the server is turned on and auto restarts the process if it crashes. More importantly, this allows me to run processes in the background, which is essential since my scripts are listeners. Now, let's look at the process itself. This handles the sound impact sensor, which is high if it detects noise and low otherwise. Using the Adafruit NeoPixel library, I've designed a script which displays the LED strip as a solid color and flashes whenever it detects a beat, thus making it sound reactive. The rainbow process uses a library that takes in microphone audio, processes it through Fourier transformation and filter banks to display specific colors for specific audio frequencies. I tried customizing this but didn't get anywhere, so that's up next on my to-do list. In conclusion, I'm pretty satisfied with this project. I managed to complete it within 2 weeks alongside other project deadlines and midterms. The reason it went so smoothly for me was because I dedicated the entire first week to research and design. This way, on the second week, I can focus solely on the software and the back end, without worrying about purchasing additional hardware. In conclusion, I would like to thank Propelland for giving me the opportunity to visit the lab. Also, thank you for listening to my demo even though the hardware wasn't working just right. I hope that this was as exciting for you as it was for me to build. Thank you.